here's another example. This case, we need to use some one-sided limits, right? So we can also use substitution with one-sided limits. We will sometimes have to do that. In this particular case, if I am asked what is the limit as x goes to 1 of f of x, I have an issue, right? Because on one side of 1, I've got this formula, and on the other side of 1, I have this formula, right? So which one am I supposed to use? I have to do it carefully. I got to break it up, okay? So let's see how this works. And what I'm going to do is I'm going to break it up, and I'm going to use those one-sided limits. And what we know, if you remember, is if the one-sided limits aren't the same, then the limit doesn't exist. If the both sided limits are the same, then that sided limit does exist. So let's see what we're going to do with this one. I'm going to start with taking the limit of f of x from the left. So from the left means I'm looking at values less than x. Less than 1. Values of x less than 1. And so if my values of x are less than 1, that's going to be here on the top part, right? So I'm going to put in this formula for f of x. Okay? And now this is easy. I just put in the 1 for x because I'm approaching x. I'm only approaching it from the left-hand side, but I'm still approaching it, so I can go ahead and put that in, evaluate it there. So I've got 1 plus 1, 1 squared plus 1. Okay, I get 2. Now, what about the other one? For the other side, I'm bigger because I'm 1 plus a small number, so I'm going to be bigger than 1. So I'm going to use this part of the formula. And I'm going to put in this x minus 2 quantity squared. Another easy limit, right? All I have to do is throw in 1. So I end up with 1, right? So clearly, this limit doesn't exist. So I can say this immediately does not exist, and I can tell you why it doesn't exist. From the left-hand side, I'm going to 2. From the right-hand side, I'm going to 1. Okay? I could have also graphed this, right, as a piecewise, as the 2 different parabolas. And it looks like there's 2 different parabolas, but they just have a jump there. I think it's quite easy to do, right? So here's 1, and this is x squared plus 1. So you can see I'm going to 2. That is just this bit. And this one is just x squared, but it's moved right 2. So that's going to be like this. And that's my function. And where do I have a closed circle? It turns out it would be here, right? Because this is x less than or equal to 1. So our graph, when we just go ahead and just graph it, looks exactly like we would expect from our math, right? So we actually did it algebraically. We didn't need to draw the picture. We drew the picture to just kind of check if what we did was right, and it looks good to me. So let's do another one. See what else I have. So I've a couple other ones written down here. So it looks nice. Okay, so let us ask about the limit as x goes to 2 of my function g of x. And again, I'm going to go from both sides and see what I get. From the left-hand side, I'm looking at numbers less than 2. I use the first guy there. Oh, let me write it like this. So it's clear that we're substituting in from our formula the right part of our formula. And there we have that. And then I put in 2, so I get 6 minus 4, so I get 2. And from the right part, left part of my formula, the right part of my formula, the number's bigger than 2. I'm going to stuff that formula in here. Minus square root of x plus 7 plus 5. Okay, so then I put in 2. I'm going to get minus square root of 2 plus 7 plus 5. So minus, well, equals minus 3 plus 5. So I do get 2. In this case, I got the same number. So we can very confidently say that the limit is actually 2. Okay. Now, in this case, if I can go ahead and graph this too as well, just so that you have this picture in your head. What do I have? Minus 4, 1, 2, 3, 4. So that would be here, here, here. Right? So that's that line. And then this is going to be like this guy, but flipped under and moved up and over. And because it's just easier to do it that way, it's going to go like this. And you can see it's going to hit kind of far out, right? Because if I let this guy this equal 0, it's going to be where this thing is 5, so that like x is pretty big there, right? X is 20, no, right, 25 minus 7 is 18, so x equals 18 it actually will cross and go down. So, but that's fine, that's what it is. And you'll notice in this example, the function is not defined at 2. We just didn't specify what it was. It has a hole in it, so what? It doesn't matter. We can still see that from both sides, the functions involved go to the point at 2. Very common, I didn't do one with an absolute value, but you often do this with absolute value as well if there's like if you're doing a limit with an absolute value, because it's a piecewise defined function. So let me skip the absolute value. I'm going to do one a little bit better, a little different. So if I have the limit as x goes to 0, say, of absolute value of x over x, this is a good question mark, right? So again, we've got the absolute value in this problem, so we have to figure out what the piecewise defined business is. Absolute value of x is x for x greater than 0 and negative x for x less than 0. I don't care where I put that one. So let's do this one. I'm just going to write it. Limit as x goes to 0 of absolute value of x. So I'm going to do this again. I'm going to do it from the left-hand side and from the right-hand side. So from the left-hand side, that would be x less than 0. So this is this. So I can put that into my thing. So that would be negative x over x. Right now I can cancel out the x's because I'm not at 0, right? I'm to the left of it, so I end up with x going to 0 from the left, negative 1. Right, because I canceled out the x's, so I just have 1. And now it's just a constant. Don't care about x anymore because it went away. And from the other side, I do the same thing. Oh, la, 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 la. I'm putting in this part now. Now the x's cancel out again, but I don't have a minus this time. So this is 1. So this ends up being 1. Of course, it's going to depend on the form of what you're taking. The limit, if I do look at the limit of absolute value of x itself, the function y equals absolute value of x, this does have, it is continuous. It has a limit of as 0 from both sides, which you can show very easily. But now if I have something a little bit different, this guy is not continuous, right? On the left-hand side, it's going to 0. I'm sorry, on -1. On the right-hand side, it's going to +1. So this example, of course, looks like this. Left, negative, right, positive. And it's just an open circle there, right? Because I can't say anything about it. Because at 0, it's whatever, 0 over 0. It doesn't make any sense.